Hello friends, let's see one very important concept of machine learning. What is regularization and why this regularization is required? What kind of benefit this regularization technique will give us while training the machine learning system? So let's try to understand this regularization with one fitting graph. So I will show you one website. I'll put that website link into description. So this is nothing but let's try to understand with respect to some fitting curve or a regression kind of curve fitting functionality, and then we will try to associate this thing with regularization, and then we'll come to know about that why this regularization is required. So what this site will give is, we have given some data point and it will just plot this data point for us. So I have listed some sample data site on this website: -1, 1, 0, 3, simple 2-dimension data point, 1, 2.5. So it has scatter displayed in a scatter plot format, this -1, 1 kind of, and 2, 2,5. It's a 2,5. So this way this has displayed all those data point in a scatter plot format. Now let's apply the regression or a fitting curve of polynomial 1. So I have they have given a very nice control here. So polynomial 1, we have tried to fit a simple straight line with respect to this data point. We can even increase this also. So let's try to observe that in a first degree of polynomial, when we try to fit to this data point, it is not nicely fitting. It is not trying to represent that data, or it is not trying to capture those underlying the relationship between this data. Let's try to improve it, or let's try to increase this degree by 2. It is getting little better and it is trying to reducing those kind of error. Let's go for even 3. It is little more better. 4, 5, or let's go for even 6, 7. So 7 is almost nicely fitting every single point. But once you go, or once you go down or decrease the polynomial degree, it is not nicely fitting those curve if you decrease it. But once you increase it, it is nicely fitting. So if you go for polynomial of degree 1, it is not representing those data. So our model is very much less complex model, but and a training is also very simple kind of way, because it needs to capture very less amount of weightage weighting term for us. But once we increase the polynomial degree, we are trying to put more and more complexity towards the our model. So we don't want a relation, or we don't want to fit our data with respect to even polynomial 1 also, even polynomial 7 also, because polynomial 7 also completely fitting those data. So it won't work well on a training data. It is working very fine on a training data, but it won't work very good on a testing data, because it is not trying to capture the underlying relationship between the this input data what we have given. So but if you see this polynomial of degree 4 or even a 5, it is somewhat trying to find or capture the relationship between the data. So it is nicely fitting, and it should be good for a machine learning system design also, because it will work very good on good on a training data also, and it will work good on a testing data also. So we have a 3 scenario. Let's try to list down this 3 scenario, and then we will see what this regularization is related to it. So let's with respect to that plot, I'll just listed here the degree. So one example is degree 1, another is a good example we found degree 5, and another example is degree 7. Okay, so first degree, it is not trying to represent the data very good. So very less data which is fitting to that particular line. So lot of lot of training error. So it is trying to underfit the data. Underfitting phenomenon is occurring in this case. And if you go to 7 degree, where almost it is trying to fit the data, so training error is very bad. Training error is very good, almost zero, but it is trying to overfit data, as it is trying to very stick to the input data. In case of polynomial of degree 7, it won't work very good on a testing data, so phenomena like overfitting occur. So in case of machine learning system design, we don't want to design a system which fits to this polynomial degree 1 also, and we need to fit the polynomial of degree 7. We need a solution which lies somewhere in between, which works better on a training data also, and it will work better on a good at a testing data also. So we can stick to the model like polynomial of degree 4 or even 5, which will work better, and it won't stick to any kind of particular data has been given to you, as it happens in a overfitting phenomena of polynomial of degree 7. So we need some kind of intermediate solution which will work better on a training data and a testing data also. But this overfitting is always occurring in a machine learning system. So with respect to all these three different use cases of different polynomial degree which we are trying to fit to our input data, how this regularization is required. So regularization is nothing but it is trying to avoid or remove this overfitting, because overfitting doesn't work very good on a testing data. So this overfitting is not good for a machine learning system design, and we are trying to avoid this overfitting, and that's why this regularization technique is used. Now how this regularization technique will be helpful? So for every single learning algorithm, while learning, we are defining one hypothesis or our error function. Our error function is nothing but your expected output minus your actual output. So expected, I'll just write is like a expected E minus actual. So that is not a very vague way of defining your error exists in your training data. But how this regularization will be helpful to avoid this overfitting phenomena? So instead of defining error function like expected minus actual one, we are trying to introduce one more word which is nothing but the regularization term. So what happened that, and that is nothing but it is trying to overcome this overfitting of phenomena. So while learning on an input data, our machine learning system, it will try to penalize this error, so it won't converge very fast to the zero, because we are introducing one more noisy term. You can't say noisy term, but one more extra term, and we are trying to penalize the error, so it will slowly decrease the error, and that is nothing but the regularization. So that case it won't just completely overfit like happens in our polynomial of degree 7. So we will get a solution with respect to this regularization technique, the intermediate solution like a polynomial of degree 4 or even 5. So mainly the purpose behind the regularization term is to penalize this error function or error hypothesis function. And if we apply those things, then overfitting phenomenon we can avoid. So basic motivation, basic idea and basic intention behind the regularization is to avoid this overfitting. We don't want this overfitting phenomenon to occur in our machine learning system, because as we have seen in a polynomial of degree 7, it just sticks with the data. It try to represent this input data very well, but it doesn't try to capture the underlying relationship between the input data. So it works very well on a training data because it has just stick to this input training data, but it won't work in a testing data very well, and that is very bad for the machine learning system. So the final in summary, regularization is required to avoid the overfitting. How we can achieve it? So we can introduce one extra term to our error function, so that error will reduce slowly, and we will get the intermediate solution of polynomial of degree 4 and 5 kind of it. So that's it for this lecture, friends. So if you haven't understood anything, please write it into comment. If you want to understand same phenomena with respect to some other example, please write into comment. And if you haven't subscribed my channel, please do subscribe it. And at last, thank you guys for the watching.